Good morning, class. Welcome to the 7th lecture video of MA269, Material Science and Engineering. So in this video, I will be discussing ferrous and non-ferrous alloys. So let's get started. So first, what is alloy? An alloy is a mixture of metallic elements which forms an impure substance that retains the characteristic of a metal. Metal atoms are typically have only few electrons in their outer shells. This means that even when they bond, there's always room in this valence electron for more electrons. So pag sinabi nating valence electrons, those are electrons na located at the outermost shell. That is why madali yung bonding between metallic atoms natin dahil laging kakaunti ang free electrons natin in the outermost shell. Since electrons are not localized in fixed bond, the atoms normally just mix to the lattice, forming metallic bonds with each other with no fixed proportions. So just like this. So makikita nyo yung atoms of two different metals natin doesn't have fixed proportion nung nag-mix sila. So compared to other types of bonding na may certain pattern or certain proportions yung atoms. So metallic bonding is a type of chemical bonding that rises from the electrostatic attractive forces between conduction electrons. So pag sinabi nating conduction electrons, it is in the form of electron cloud of the localized electron, which is free sila mag-move, and positively charged metal ions. So it may be described as the sharing of free electrons among a structure of positively charged ions. So, metallic bonding accounts for many physical properties ng metal natin, such as strength, ductility, thermal and electrical resistivity, and conductivity. So, ang tawag natin sa ganitong formation is alloys, no? Kagaya na banggit natin kanina, combination of two metallic elements or metals. On the other hand, kapag sinabi natin compounds such as this, may certain portions or positioning ang ating pinag-combine na atoms. So, ang compounds, nangyayari lang yan sa metal and non-metals or non-metal to non-metal. So, example ng compounds are polymers or ceramics, that is compounds. And then, the bonding between them, depende, no? Pero hindi metallic bonding yon, either ionic bonding or covalent bonding. So, types of alloys, meron tayong dalawa niyan. First, ferrous alloy, which defines as the alloys that consist mostly of iron or Fe. And non-ferrous alloys, they are alloys that doesn't have a significant amount of iron in its chemical composition. Meaning, hindi siya ganun karami or technically wala talagang iron dun sa ating alloy. So first, let's talk about ferrous alloy. So ferrous materials or ferrous alloys, maraming classifications, no? So discuss natin. So yung ferrous alloys natin is divided into three kinds. And they are first, wrought iron, steel, and cast iron. The difference between the three is the amount of carbon in their alloys. Kasi typically, carbon yung main alloying element ng ating iron or ferrous material. Because carbon increases the hardness property ng alloy natin. So, yun yung characteristic ng carbon, no? Pinapatigas niya yung characteristic ng isang iron. Because pure iron, ang characteristic niya commonly is, so, sobrang ductile siya. Pero yung hardness niya is hindi ganun kataas. So, the more we increase the carbon as the alloying element, what will happen is the hardness of the material will increase. So, pag sinabi nating wrought iron, the amount of carbon as the alloying element is sobrang liit lang. Steel, medium amount of carbon. If the alloying element of carbon is malaki, that is cast iron. And then, subdivided yung steel. So, they are low alloy and high alloy. When we say low alloy, kakaunti lang yung alloying element bukod sa carbon. And we say and when we say high alloys, they are the metals that have different kinds of alloying element bukod dun sa iron and carbon natin. Subdivided pa yan. So yung low alloy natin is divided into three: low carbon, medium carbon, and high carbon. And then all of them is subdivided then. So we have plain, high strength, plain then for medium carbon, heat treatable, plain, tool steel, and then stainless steel. The stainless steel is considered as high alloy element because the stainless steel comprises a huge amount of chromium on its properties or its composition. Cast iron naman natin, divided siya into 5. They are gray iron, ductile iron, white iron, malleable iron, compacted graphite iron. Later on, i-discuss natin yan isa-isa. Next, let's talk about wrought iron. So wrought iron, it is an iron alloy with a very low carbon content, less than of 0.08%. So ganun lang kaliit, no, yung carbon content sa kanyang composition. So the characteristic of wrought iron, it is a tough malleable form of iron suitable for forging or rolling rather than casting, obtained by puddling pig iron while molten. When we say pig iron, this is the first byproduct of steel making or steel process. So wala pa siyang ganong hinahaluan na alloying element. So typically, huge percentage of iron or masyadong purong iron ang meron doon. So sa halip na ginagamitan siya ng casting, commonly kasi casting eh, no? So ang processing ng wrought iron natin will be forging or rolling. Next, steel. So steels are iron-carbon alloys that may contain appreciable concentration of other alloying elements. So the mechanical properties are sensitive to content of carbon, which is normally less than 1% of weight. So mas mataas siya compared sa wrought iron natin. So alloy steel, it is steel that is alloyed with a variety of elements in total amounts between 1% and 50% by weight to improve its mechanical property. Kapag pataas ng pataas yung percentage ng alloying element, that is considered as high alloy element. So let's talk about alloying elements. So first, chromium. Nagdadagdag tayo ng chromium sa ating material to add hardness and increase toughness and wear resistance. Kaya ang mga stainless steels, no, matitigas na materials 'yan. And of course, chromium also gives the iron alloy natin as uh, so of course chromium also gives the alloy element natin. So of course, chromium also gives our alloy material a property of resisting corrosion or rusting. Next, cobalt, another alloying element. It improves hot hardness for applications such as cutting tools. Manganese, it increases surface hardness and resistance to strain, hammering, and shock. Molybdenum, on the other hand, it increases strength and resistance to shock and heat. So, nickel, it increases strength, toughness, and corrosion resistance. Tungsten adds hardness and improves grain structure and heat resistance. Vanadium increases strength, toughness, resistance to shock, and corrosion. So all of them are metal alloying elements na commonly used on steel alloys natin. So hindi lang basta isang alloying element ang usually nilalagay, minsan combination of them. So common combination dyan lagi is chromium vanadium, chromium molybdenum, nickel chromium molybdenum. So depende dun sa gustong physical property na or mechanical property ng ating material, may certain percentage of this alloying element ang nilalagay. Okay, na-discuss natin kanina na ang ating low alloying elements is subdivided into three, and they are low carbon steels, medium carbon steels, and high carbon steels. So first, let's talk about low carbon steels. So low carbon steels, steel that contains less than about of 0.25% weight carbon and are unresponsive to heat treatments. So yung heat treatments kasi, yun yung ginagawa natin sa material natin wherein ini-increase or dinidecrease natin or fast decrease at temperature of the material to increase the physical properties. So since mababa masyado at yung percentage ng carbon natin, hindi na siya responsive sa heat treatments. So hindi na possible yung mga heat treatments. So strengthening is accomplished by cold work. So para ma-accommodate yung kawalan ng response sa heat treatments, meron pang isang method to increase its physical properties, which is by cold working. So example of low carbon steels are first plain carbon steel. So it contains only residual concentration of impurities other than carbon and a little manganese. So ano lang, wala kang ganong karaming alloying element na nilalagay. So basically, they are only iron, a small amount of carbon which is around 0.25 and less or less, and then other impurities other than little manganese. So another example of that low carbon steel is high strength low alloy or HSLA steels. So they contain other alloying elements such as copper, vanadium, nickel, and molybdenum in combined concentrations as high as 10% and possesses higher strength than the plain low carbon steel. So since nilagay ka ng other alloying element, kasi 'di ba puro lang 'to bukod sa carbon and little amount of manganese. Ito since naglagay ka ng other type of alloying element, kagaya ng mga bigkas ko kanina, no, na-discuss ko, na-increase yung mechanical properties niya. So mas matigas siya or higher strength than the plain carbon steels. Next is medium carbon steels. So steels have carbon concentration between about 0.25 and 0.6% of carbon by weight. So ganon kalaki yung effect ng carbon, no? Kahit kakaunti lang yung dinagdag in terms of percentage, na-differentiate siya due to the different mechanical properties. So these alloys may be heat treated by austenitizing, quenching, and then tempering to improve their mechanical properties. So these are types of metal workings wherein it improves the mechanical property of the material. I-discuss natin siya for susunod nating topics, no? So next, high carbon steel. So steels that normally having carbon content between 0.6 and 1.4% by weight. And the hardest, strongest, and yet least ductile of the carbon steels. So sa tatlong low alloying steel, which is yung low, medium, and high, ito yung pinaka matigas and pinaka strong sa lahat. At as you can notice, ito din yung pinaka less ductile. Kagaya ng nabanggit ko kanina, the more you increase the carbon content of the material, it increases the uh, strength of the material but it reduces the ductility. Kasi yung pure iron natin, sobrang ductile. No? So they are almost always used in a hardened and tempered condition. Kaya usually, ang mga materials natin undergoes a heat treatment and other treatment in order to increase the mechanical properties. So example natin ng high carbon steel that will be tool steel, which is steels having distinct characteristics such as hardness, wear resistance, toughness, and resistance to softening at elevated temperature. Example siya ng high carbon steel. So usually nakikita natin siya sa mga tools, sa mga bits na ginagamit. For example yan, yung drill bits. So tool steel yan. So ginagamit siya sa mga ganong conditions because of its distinct characteristic. So they are high carbon alloys usually containing chromium, vanadium, tungsten, and molybdenum. So next, stainless steel. Stainless steel is an example also of high carbon steel, and it is also under high alloying steel. So it is highly resistant to corrosion or rusting in a variety of environment, especially the ambient atmosphere. So their predominant alloying element is chromium. A concentration of at least 11% weight of chromium is required. So kaya siya na-consider din as high alloying element because it is composed of huge amount of chromium, 11%. Next, let's talk about cast irons. So they are classed of ferrous alloys with carbon contents above 2.14% by weight of carbon. In practice, however, most cast iron contains between 3% and 4.5% weight of carbon. So, malaki yung amount ng carbon content ng iron natin. So, of course, these types of iron has high in strength but low in ductility. So, kaya din siya tinawag na cast iron because the method of forming the metal is by casting. So, i-discuss natin yan sa future lecture videos natin, no? Yung mga types of metal formings. So, on the other hand, yung wrought iron natin can be done using other forms of metal forming bukod dun sa casting natin. So, first example of cast iron is gray iron. So, kaya siya tinawag na gray iron because of its color. So, the carbon and silicon content of gray irons vary between 2.5 to 4% by weight and 1% to 3% by weight respectively. So, yung carbon content niya is 2.5 to 4%, no? And then the silicon content niya is 1% to 3%. So, a type of cast iron that has a graphitic microstructure. So, it is the reason why the physical property niya or physical color niya is gray dahil sa graphitic microstructure niya. So, it is named after the gray color of the fracture it forms, which is due to the presence of graphite. So, common na ginagamit siya sa casing ng engine because of its high toughness and hardness, no? Kasi nabanggit ko nga na mataas yung percentage ng carbon. Next, another example of cast irons is ductile or sometimes called nodular iron. So, adding a small amount of magnesium and or selenium to the gray iron before casting produces a distinctly different microstructure and a set of mechanical properties. So by adding the magnesium and cerium to the to the alloy natin, it increases the ductility kaya siya tinawag na ductile iron. So, graphite still forms, but iba na yung form niya in its microstructure. So, nangyari, nodules yung shape niya, or sphere-like particles, parang nodes, no? Nodes. Sa halip na flakes. Kasi dun sa gray iron natin, the microstructure of graphite is in flakes shape, no? So, dito, nodules na siya. Kaya siya tinawag din na nodular iron. Ito yung example niya. So, Another example will be white iron. It is a type of carbon alloy that contains carbon content greater than 2% in the form of cementite. So iba na, no, hindi na graphite, no. Cementite na yung formation, no, microstructure natin. So they display white fractured surface due to the presence of an iron carbide precipitate called cementite. So due to the cementite, which is white in nature, kaya puti din yung nagiging surface color ng ating white iron. Next, we have compacted graphite iron. So silicon content ranges between 1.7% to 3% by weight, whereas the carbon concentration is normally between 3.1 and 4% by weight of carbon. Usually ginagamit din siya sa casing ng engines, no? Because of its high toughness and hardness. So it is a metal which is gaining popularity in application that requires either greater strength or lower weight than other type cast iron. Because compared to the other type of cast iron, kasi lahat naman talaga ng cast iron pwedeng gamitin as uh, in applications wherein it undergoes a lot of stresses because mataas nga yung toughness and hardness ng materials natin. Pero compared to them, our compacted graphite iron has lower weight compared dun sa others. Next, let's talk about non-ferrous alloys. So first, let's talk about copper. So copper and its alloys. Copper is an example of non-ferrous alloys, no? So it is a soft, malleable, and ductile metal with very high thermal and electrical conductivity. Kaya siya ginagamit as a main uh, material in conductors natin or wirings. So first, let's talk about brass or an example of copper alloy. So it is an alloy of copper and zinc in proportion which can be varied to achieve varying mechanical and electrical properties. Because yung copper natin and its alloys have different grades. Kasi sa mga material may tinatawag tayong grade. Yung grade, nakadepende yun sa certain percentage ng mga alloying element. So, different grades have different mechanical properties. Kasi yung mga different properties na yun, pinagagamitan natin yun sa different applications din. So, yung brass, nagbavari syempre yung proportion niya ng copper and zinc. And minsan, binibigyan din siya ng other alloying elements, no? To differ or to increase the mechanical property. So it has higher malleability than bronze or zinc. Bronze is another form of alloy ng copper. So it has low melting point, workability, durability, electrical and thermal conductivity. Next, let's talk about bronze. So bronze, another type of copper alloy. So it is an alloy consisting primarily of copper, commonly with about 12 to 12.5% tin, and often with addition of other materials or metals such as aluminum, manganese. Next, let's talk about bronze. Bronze is another example of copper alloy. So it is an alloy consisting primarily of copper, commonly with about 12 to 12.5% of tin, and often with the addition of other metals such as aluminum, manganese, nickel, or zinc. So yung common alloying element sa bronze is tin. So kanina, no, ang pinag-combine natin for brass is copper and zinc. So in this bronze material naman natin, combination siya primarily ng copper and tin. So these alloys are somewhat stronger than the brasses, yet they still have a high degree of corrosion resistance. Next, let's talk about aluminum. So si aluminum is an example of non-ferrous material. Aluminum, it is a silvery white, soft, non-magnetic, and ductile metal that has an ability to resist corrosion. So meron din siyang property, no, to resist corrosion. So, similar to the, to stainless steel. Kaya minsan, ginagawa siyang kapalit ng stainless steel as a material because aluminum is much cheaper compared to the stainless steel. Pero of course, yung mechanical property nila is magkaiba kasi di hamak na mas mataas yung mechanical property ng stainless steel. So, common example na ginagawang substitute si aluminum is a ducting system. Of course, hindi naman talaga kailangan ng high strength sa mga ducting materials. So for example, yung sa mga clean rooms, no? And hospitals wherein kailangan talaga ng malinis na hangin. So bawal ka gumamit ng other type of sheet metals bukod dun sa mga corrosion resistant materials such as aluminum and stainless. So, since mura si aluminum, yun yung ginagamit as replacement. So it is characterized by relatively low density, which is 2.7 gram per cubic centimeter as compared to 7.9 grams per cubic centimeter of steel. So di hamak na maliit ang ang amount of density ng ating aluminum. So the chief limitation of aluminum is its low melting temperature, so which is 660 degrees Celsius. So, bawal siya gamitin sa mga high temperature condition. So, yun yung kinalamangan ng steel sa kanya because steels can work on high temperatures. It is also very soft material and can easily be scratched, which is visible naman talaga. Next, let's discuss the uses of aluminum alloys. So first, ginagamit siya sa aeronautics. Kasi sa mga gantong applications, very important yung weight. So, dapat kailangan lightweight yung material. So, ang ginagamit dito is higher grade of aluminums para mataas din yung mechanical properties niya. Next, automotives. So, common na ginagamit ngayon yung mga aluminum alloys, no? So, meron na ring lumalabas na aluminum monocoque as the main frame ng body ng sasakyan because it is more lighter. So, electrical conductors. So, ginagamit siya sa mga overhead transmission lines. So, minsan kapalit siya ng copper or minsan ito talaga yung ginagamit as main conductor. Food packaging and utensils, common yan. Yung mga foils, tsaka yung mga aluminum packaging natin. Marine applications, structures, no, sa mga buildings, no? Windows, ginagamit yan, aluminum. Screens, sporting equipments, because of its lightweight, magamit din tayo ng higher grade aluminum alloy dyan. Next, let's talk about magnesium. Magnesium is another example of non-ferrous alloy. So, the most outstanding characteristic of magnesium is its density of 1.7 grams per cubic centimeter. So, mas magaan pa siya sa aluminum. Kung nagagaan ka sa aluminum, mas magaan po si magnesium, which is the lowest of all structural metals. Magnesium is relatively soft and has a low elastic modulus. Ito lang yung downside niya. Na ang magnesium is very soft. Na ang elastic modulus na is 45 gigapascal only. So, aluminum, zinc, manganese are the major alloying elements for magnesium alloys. So, these types of alloying elements increases the mechanical property of basic magnesiums. So, uses of magnesium and its alloys are, first, structure. Aircrafts, ginagamit yan because kailangan ngayon ng mga low weight materials, no? Handheld devices and tools. Automobiles, so common na ginagamit yan sa mga steering wheel, seat frames, and transmission cases para mapagaan yung vehicle, ginagamit yung magnesium alloy doon. So kung mapapansin nyo, lahat ng example nito sa automotive or automobile application, hindi nabibigyan ng huge amount of stress because of course, malambot nga masyado yung magnesium alloys natin. So ginagamit din siya sa audio-video, computer, and communications. Lastly, our last example of non-ferrous alloy or non-ferrous material will be the titanium and its alloys. So titanium and its alloys are relatively new engineering materials that possesses an extraordinary combination of properties. So matigas to masyado, no? So titanium alloys are extremely strong. Room temperature tensile strength as high as 1400 megapascal are attainable, yielding remarkable specific strength. So sobrang tigas, sobrang taas ng kanyang tensile strength. Furthermore, the alloy are highly ductile and easily forged and machined. The major limitation of titanium is its chemical reactivity with other material at elevated temperature. Therefore, mahirap siya i-produce, no? So this property has necessitated the development of non-conventional refining, melting, and casting techniques. So since unconventional yung kanyang process, the titanium alloys are quite expensive. So siya din yung pinakamahal sa mga non-ferrous alloys. So that will be the end of my lecture. If you have any question, you can message me on my messenger or email me. Thank you.
Fire.
Emmy, faculty, yeah. Emmy, faculty, yeah. Emmy, faculty, yeah. Emmy, faculty. Siya naman si Sir Ivan Espinosa, dulo ng pangalan. Pangako di mahihirapan at hindi kanya iiwan.